So you can see what is on the board. Lecture 6 is a frame ABC carrying a uniformly displayed load of 15 kilonewton per meter and a pointed load of 2 kilonewton at point C. Now, just like the other frames we have been dealing with, but this one has two loads, a UDL, which is 15 kilonewton per meter, and 2 kilonewton pointed load at point C. Now, to start, the moment at C is 0, clearly. Reaction A is the sum of the loads that are, because there is only one support, and that is the load 15 times 5 as a concentration of load plus the 2. So that gives 77 kilonewton will be the reaction. So at point E, the bending moment is 2 times 2.5, perpendicular distance, 2 times 2.5. Look at it, 2 times 2.5 minus 2 times 2.5 minus 15 times 2.5 times 2.5 over 2. That is how we have 15 times 2.5 squared over 2. That is the moment at E. The moment at B, minus 2 times 5, the length, then minus 15 times 5 squared over 2, which gave minus 197.5 kilonewton meter. Now at F, the moment at F is equal to that minus 197.5 kilonewton meter, because F is the length BF is not perpendicular to the action of line of the loads. It is parallel, so it will not multiply the load. The load will only multiply the perpendicular distance, which is between EC or BE. That's why the bending moment at F is equal to what we got at B. And such moment at BF is concentrated now. That's why at MA, the moment at MA is also equal to 197.5 kilonewton minus 197.5 kilonewton meter is concentrated. And this is the bending moment diagram. Because if you look at the equation of the bending moment, right, from ME, MA, MB, and so on, the bending moment is a curve, because the equation is quadratic and the graph of a quadrant is a curve. That's why it has this curve. 0 at C and 197.5 at B. And from B down to A, the moment is concentrated. It was given the same value. And that is now why it is a rectangle. It's a rectangle. And the same value, 197.5. This is why this is the bending moment diagram for the frame. Then the shear force of the frame. The shear force at C is minus 2. As we move on, at point B, the shear force is the 2 plus 15 times 5 to get as a concentration of load, because the load is 15 kilonewton per meter, 15 kilonewton per meter. So for 5 meters, it's 15 times 5, which is 75, plus 2, that is 77 minus 77. And the load was varying. That's why the shear force diagram was varying from 2 to 77. There's no shear force on BA, on member BA. There's no shear force. Where shear force occurs is where the force is across the member, is on the member, and if the line of action of the force is across the member. So the next one is the normal force, because there's normal force in BA, in member BA. The force in BA is normal force, which is the whole forces. It's like a column carrying the whole forces, which is 15 times 5 plus 2, which is 77 kilonewton, sorry. And the same thing, it was the same thing throughout the member on BA. So these are the bending moment values and bending moment, shear force values, bending moment diagram, shear force diagram, and normal force diagram for this frame loaded as shown on the board. Thank you very much. That's the end of this episode.